Hello, everyone. So we are now live, right? Hello. Yeah, I see you're writing, typing hello, and I'm really excited about this event. Okay, so I will spend some time on describing you our agenda while our speakers are getting ready. First, I will make a short introduction about myself and why I'm here, and why I'm so excited to be here right now. Later, I will tell you the mechanics, how everything will work tonight, because it's online and it's streamed. So and then I will invite each speaker one by one and let them introduce and say some words to you before they will start. Okay, so. A short introduction, as I promised. My name is Pavel Shigelski, and I'm here as a moderator of the session. I work as an Android developer in a product company in Belarus called Flow Health. It's a health platform for women. Maybe you know it already, but I will just remind you a bit. What is Android Academy? Android Academy is a big community where people learn the Android framework. And we help each other, we support each other, we share ideas and experience. And of course, have fun, right? Why not? Okay, big Android Academy, it's like a big family for those who are interested in Android ecosystem. And that's why I'm here right now, because I believe that I can help others. I can share my experience. I can improve my technical skills. I can share my ideas, and of course, vice versa. Why not? Android Academy is split in different locations. Right now, it's in Israel, it's in Belarus, and of course in Russia. So, by the way, I didn't say that today our session will be only in English. So please, but you can ask your questions in any language you like, in Russian, in English, it doesn't matter, in the chat. Okay. And I'm a bit excited because it's an opening session. It's of our new initiative called Deep Dive in Features of Android 11. You know that Android 11 is like nine weeks of Android 11 and everything. So we decided to make this activity in order to deep dive into the features of the most important features of Android 11. It will be 5 meetups every 2 weeks. So with our experts, we will cover the most important changes because as Android developers, we should be ready for them and we should know how to handle it right. And today, we will talk about privacy and security. As a user of Android operating system, I'm really excited about those changes and I'm really waiting for them because why? We will know it later at the end of the session. Before I will introduce our speakers, and I want to get acquainted with our audience and with those who are right now who is listening to us. And can you write in the chat where are you from, or where you can you describe your place where you listen to or watch our stream? I would love to take a picture of your place to see to ask you to take a picture of your place, but really, it's impossible because it's a YouTube chat, right? It doesn't support it. And so the next thing that I want to while you're writing your answers, I want to describe you the mechanics that will work today, tonight. So as we are online, right? So each speaker has a presentation. It's about 30 or 40 minutes. After each session, we will have a Q&A session, and where you can ask your questions, and I will read your questions. So please don't be shy. Please be active. Ask your question because it's a wonderful moment when you can share your problems and together we can resolve them, or you can just talk to our expert. So it's a great moment, I think. And of course, your questions you can write in English, in Russian. We can translate it. It doesn't matter. So please be proactive. And as I mentioned earlier, yeah, this session is online. We all goes online, right? So if you have any problems with the stream, just try. The first thing you can do is just to reload the page and see if it helps. If it doesn't help, you still have some problems, please let us know. Just write it in the chat, and we will handle it. Of course, by the way, we added links to Telegram chats for all locations, so you can write your questions as well there. So we will monitor those chats, and we'll ask our speakers, our experts, those questions as well. Yeah, that's it. I think that you got the main mechanic of our session. And I want, yeah. So let me see where. Oh, yeah. I see so many people from Moscow, from Samara, from Russia, from Israel. Oh, great. Yeah. By the way, we made this session in English in order to because the Android Academy is split in different locations, and we want to and deliver this information to all the locations. So, okay, great. I see. By the way, I didn't mention that, but yeah, we have a latency in our stream. So please be patient. We have a latency about, as measured, it's about 20 seconds in chat, but in stream it's almost like maybe 5 seconds. So we will try to look for your questions. Okay, that's enough for now, and I will invite the first speaker. I think you know this guy. You know him. He's quite famous in the Android community. It's Jonathan Levin. Hello, Jonathan. Welcome. How are you?
Great. I'm really excited. I have to say that we were thinking a lot about how to do this event and how to prepare it, how it's going to be online, because always we were doing it offline, and we know how to make them offline. For us, it's the first time online event, and there is a full excitement. Of course, we will have a lot to improve for the next time. And this is the first one. We will learn from it. Also, all questions about the quality, we're trying to fix it as much as we can. It's crazy. Yeah. I personally can say that I work on these presentations like nights and weekends. Our leadership team know how was it hard. But yeah, I think it's a really good deep dive and can give a common ground. And I'm very excited for the first time that we have all Android Academy from different parts of the world, from Israel, from Belarus, from Russia, joining all forces to learn together and utilize the online platform. See how it goes.
Yeah, that's
very excited.
Yeah, and we have already the first question about the stream. Yeah, it will be available. It's recorded, so it will be available. Okay, good. Thank you, Jonathan. I think that we can invite our second speaker. It's Vadzim Vysotsky from Minsk, directly from Minsk. Hello, Vadzim.
Hello,
how are you?
Hello. I feel amazing. It's so nice to be here to speak to you. I can't wait to share my researches about Android 11 features. I really like them. So.
Yeah. You know, I feel like I'm on the European continent when everybody is calling to different countries and they are welcoming each other, waving their hands, and so on. So it's amazing that right now all the borders are closed, but we can meet each other in online in this atmosphere. Great. And the last speaker, it was our secret guest, but you know already his name. Yeah. It's Yasin. Hello, Yasin, directly from Google, directly from London, right?
Yeah.
How are you? Yeah.
Hello, everyone. Happy to be here. I think it's the first, well, it's online meetup, but first meetup I do with the Russian, Israeli, and Eastern Europe community. So Thank you for having me.
Yeah. We too. We are happy. We are happy that you joined us, and I hope we are looking forward to your insights about the privacy changes and everything. So
Yep.
yeah, today I really enjoyed this session because I already listened to some of the presentations during the dry runs, and I got some insights from those presentations. So be ready for an action. Okay, I think that we are ready, right? We are ready to start our meetup, to start with the presentations, right? How are you? Do you think? Yeah, okay.
It's
Thumbs
time.
up. Yeah, okay, good. So we go in the opposite direction. We will start from Yasin. Then we'll go with Jonathan and Jonathan
Vadim.
and then with Vadim. Okay, it doesn't matter.
No, opposite. Vadim and then Yoni.
Yes, Vadim and Jan. Right. Yeah. Okay, so I will leave just a second. Okay. Yasin, can you share your screen?
Yeah, let me do that.
Okay, so we will edit.
All right. Is it good to
Okay,
go?
yeah, I see it. Okay, so
Perfect.
I will remove myself, and so you can continue. If you need any help, just ask.
All right.
Okay, okay, good.
So, hello everyone again, and thank you for coming to my talk. Not only the one, you gotta stay for the next ones too. On Android changes related to privacy on Android 11. For the ones who don't know me, my name is Yasin Razgi, and I'm a developer advocate at Google on the Android team in London. So the first thing, why people keep talking about privacy, why it's so important, we have to know that tablets, smartphones are now such important devices for users holding their personal and private data. On Android, privacy is an area where we have been evolving over the last several releases, and we're continuing to do so on Android 11. So on Android 10, we brought some changes in that direction for us to evolve our platform to bring even more protection for users' data. So today we will talk about some new enhancements in Android 11, permission changes, scope storage, foreground service types, package visibility, and data access auditing. Some of them will be deep dive more in details with Jonathan, with the next speakers. So bear in mind, I'm doing more of an overview, but you gotta stay for the next talks. So first, let's talk about permission changes. For the ones who have been checking Android 11 beta, we introduced the one-time permission. Let's get a bit what's all about. So what we found is whenever they're given a choice, users, they always prefer to share less private data with their apps. Some apps ask for background location access, for example, without needing it. So what we thought is, based on the users and developers' feedback in Android 11, we're bringing users more granular control over device private sensors. So location, camera, microphone, and significantly limiting the access to background location. So here the goal is to give them more control. It's not to stop what you can do on Android, it's just to give them more control. So let's take this screenshot, for example. In this case, the users will be able to grant a temporary one-time permission for location permission request. And it will be the same also for microphone access to. So what does that mean is when you have an activity being on the foreground, so if your activity is visible or on the foreground, you will have access to that permission. But as soon as your activity goes into background, paused, or the user closes it, you won't have it anymore. But why it's that good? So you may have some apps where you want to stream directly, for example, like YouTube. So giving it all the time makes sense. But let's imagine you have an app from a company that you use their services, and they integrate a functionality for you to call their support. Maybe you need to share, obviously, your microphone to be able to talk during that phone call, but maybe you just don't want to give it all the time. Same thing for location and also for video. It's just about the idea of you just give it when the app actually needs it, rather than giving it all the time. And for developers, you may have this important question in mind: is do I need to change anything to work with one-time permission? Because obviously we don't want to change the code that just works. And actually, most of the time, I would say you don't have to change anything if you are already following the privacy best practices. So what does that mean? Let's get more into details. Let's take this screenshot of an app. So here, for example, when you click on location, normally in your code, this is Kotlin code, again, same, just works in Java. Obviously, I prefer Kotlin here. I will check if I have the permission, if it's already granted or not. And in that case, I just perform the action, I just do the logic there, nothing changed. And after that, I should call, and that's one of our privacy best practice, we call the should show request permission rational, which here basically, based on the situation, the system will check and provide a context to the user or not, to say like, you need to have this permission request to be able to access support. So to give context rather than getting it denied straight away. And if you don't need to show any rational, again, the system chooses for you. You will just request permission in the else condition there. So what does that mean? How there is no change for us? Well, even before 111, a user can deny permission. So it may authorize, but after that, he may go. The user may go to the settings and may change the permission, may deny it, or since Android 10, we will show once in a while a notification to say, hey, this application has been using your location or your microphone, and users are more keen to revert the permission grant if they think the application doesn't need that permission anymore. So you should never assume you always have the permission. You should always check, which is the case for a really long time on Android. And here is just even more enforced. So if you have it during the foreground labs where your app is being on the front or as a foreground service, nothing changed for you. You will just have access. Again, always check if you have the permission or not. But let's take the case where where the user pressed deny. In such case, you will have the on-request permission result callback that will be invoked. And the permission was rejected, and we should make sure to explain to the user which functionality won't work, like that they get a context. Because sometimes you already had that experience where an app may just ask you straight from the beginning when you open the app, give me that permission. Most of the time, users actually don't like that, and there is a high percentage they might just refuse it. So here, in the case if you're rejected, always make sure you're providing more context. So for your example, in this screenshot, we may just show a snug bar to say, I may need that to be able to provide the location context for the support to help you further, for example. And I know a lot of you have been using already on request permission results. Is whenever you have to deal with intent or whenever you request for permission, that will be the method you will have to implement. So you just override it, and after that, you check when the request code hasn't been granted or not. We introduced activity result. It's an API which is part of the activity and fragment libraries, the Jetpack libraries. And it really simplifies using interacting with intents or asking for permissions. If you're interested, have a look, write activity result API on Google. You will certainly find it, and it's really, really good. It's still in alpha, but on all my code sample that I've been using it highly simplified my code base, so I highly recommend you to have a look there. So to give users fine-grained control, in Android 10, we split the permission between foreground and background location access. So in this, what we did in Android 10 is allowing the application to say, actually, I just need that for the foreground. I don't need it all the time. And apps are encouraged to incrementally request this permission to give users better control. So first foreground, so to give a context, I needed to show your location in a map when you request a taxi, for example. And after that, foreground to maybe propose recommendations of restaurants nearby you. So not from the beginning you request the background location. So that was a recommendation, and in Android 11 this pattern has become a requirement. So now you can't ask straight away for background location. You will have to ask first foreground and after that background. So there is no change for foreground access requests. This will be adequate for most use cases. Again, here foreground doesn't mean only when your activity is on the front. You will have the active notification, so you can still have a foreground service, so service still working there, but it will be visible for the user. It won't just happen in the background. It's once the user closes your app and close that foreground service, you won't have access to it anymore. It's just, again, here to bring more control, more transparency to users. And for background access, when you target Android R, there are two changes. First, it's good practice to incrementally request permissions to give users a chance to understand and decide based on context. So they could, instead of asking for foreground and background together, you should only ask for background location after you have been given foreground access. Again, here, incrementally asking. And this pattern, again, as I said, was recommended on Android 10, and now it's a requirement on Android 11. And when your app requests background location permission, the request permission API would send a user directly to the settings instead of a regular permission request dialog. So that will be also the difference is before you will have just the dialog, the model on the app. Now they will be sent to the settings. Like that, they are aware it's they're giving a proper context on the permissions. So it's a good practice to educate the user before requesting the extra permission with some sort of explanation UI, because again, if from the beginning, as soon as they open the app, they're moved directly to the settings, they won't understand it. So that's why you should say, hey, if you want recommendation about restaurants, click on this button, and at that moment, you will be able to send them to the settings for them to understand what's happening. And you need to make sure to provide the option for the user to refuse, because there is a rate limit. If the user refuses 2 times the permission, you won't be able to ask for that permission anymore. Doesn't mean it's over, game over for you. No, don't worry. They can still go to the settings by themselves and authorize it again. But you won't be able to send the intent and show that settings page if you have been denied 2 times. Here again is the idea that if the user doesn't want, it's certainly because you didn't explain them what's the use case there. So make sure you get them in the right context, you explain properly before requesting that permission. So we made it easy for developers. We're not introducing new APIs. There is more like a UX recommendation that is now in practice, but in terms of code, it's still the code that you were using before. And apps get to control the UI for most of the process. So again, here, it's not coming straight when you install, it's only when you actually request it. So you can show an explanation, model, or snack bar before requesting the permission. You're still in control of that. So to ensure compatibility for apps targeting Android 10, so API level 29, because maybe your application have been targeting Android 10, in terms of planning or priority, you couldn't target Android R. It will still be allowed to request both foreground and background location permission at the same time, but only if you target Android 10. And remember that every year we upgrade the requirement on the target SDK, so it's just a temporary way for you to ensure the compatibility. And the extended dialog will be shown instead of going to the settings. But again, it's just a temporary compatibility alternative. I highly recommend you to follow the best practices I've been mentioning so far. Okay, so that was for one-time permission, which is already a lot. Now let's talk about a new support for apps to discover potentially unintended access to private data. So some of you may have heard of the data access auditing API we're bringing. Let me explain you that in details. So as a best practice for building mobile apps, is to ensure transparency for accessing private data. For example, it should be clear and obvious to the user why a voice application needs access to their contact information if they need to make a phone call, for example. Here, the goal of why it's really important to be transparent to your users, because we saw some application in their reviews, some users complaining, I don't understand why this application is asking that permission. Why are they using my microphone? Why are they using my location? Here, whenever you're accessing a private data or private sensor data, you should make clear to the user you're going to actually use it, and you should explain why will you use it. But the problem is for big application, for companies where there are so many people working on the same application, there are some challenges in identifying data access in their code. You may have large apps, often have large teams, and sometimes you even have orphan code inside. So some code that no one knows that exists because someone wrote it and left the team and no one took care of it after. So sometimes you can access some private data, some private sensor without even knowing it, because it's some code that disappeared from your memory or from the team's memory, but is still in the app. Sometimes you may use a third-party SDK, closed source or open source, a library that will access private data without even giving you knowledge of that. So your application may not be the culprit there, but you may use a dependency that is a problem. And in both cases, this access pattern may or may not be intended, but it's not always easy to identify. Especially when you have so many ways to access your location, contacts, or microphone within the same code base. So if you have 500 lines of code, it's a lot, but for developers we're used to. But you may have application with hundreds of thousands, if it's not even millions of lines of code. And there is just, you may be using a lot of libraries, you may be even using different languages. It's just so hard for you to master your whole app code. So therefore, on Android 11, we're providing 2 new APIs to bring developers back in control over their app's data usage. The basic feature is a callback when data is accessed. On top of that, we allow the developer to attribute access to logical features within the app. So in this picture, to figure out how it works, in this picture, each blue line represents a piece of code in the app, and the gray lines symbolize that this code accesses certain private data. That's usually in your stack trace, this is how it is. It can be a module, it can be an activity, a fragment, or your own Kotlin and Java file. It will just be different pieces of code. Whenever an app calls an API that returns private data from these sensors, so location, contacts, or microphone, the system calls into a collection handler immediately before returning to the calling code. So hence, at this time, the collection handler can collect a stack trace to record which code performed the access. It may sound a bit verbose, but let's look at the API. It will be clear to you. So this shows how to set up a callback for data access through the App Ops Manager class. So whenever you need to access one of those sensors, usually you need to get the App Ops Manager getting it as a system service. So from your context, you need to get this instance of class. So if you want to consistently track for the entire app, you can set it up within application on create. Like that, you're clear, you will always get it. Say you want to localize it to a particular part of your app. You could do it within activity on create. So like that, we know in the setting page or in the support page, in the welcome page, etc. And within the on-up noted callback class, your app will be notified of data access in synchronous calls. So this happens when you will use directly one of those sensors. And the asynchronous access is, for example, when your app registers a callback listener. So I know if you use the geofence API type, that's not a direct call. It's like you just say, I want to listen and notify me when there is an update. I will get it. But let's see more in details. How can we understand it? What basically it will do is whenever you call one of those sensors APIs, that callback will be called. But again, maybe you have just so much code, it's hard to figure out which code actually called that. So what we can do is we can actually contain multiple distinct features tagging. We call that an attribute tag. And here, basically, for each module of your app, you can specify a name of a tag, in this case, navigation, find friends, explore nearby shopping, or default. And whenever that callback will be called, you will receive that tag. So how do we create a tag? So again, as I mentioned, we need to get the context, usually from our activity, to be able to access one of those system service and get those private sensor data. Here, rather than just doing activity.getContext, I think, or in Kotlin, we just use .context property. Here we will call create attribution context, and we'll give it a string, so a tag to identify it. So whenever this specific attribution context will make a call to one of those data, we will label those calls with this specific tag. Like that, we're aware that find friends actually made that call and not the nearby shopping area module made that call. So like that, we can identify. And in your callback, so on the onNoted, on one, the attribution tag property will show that. So the good thing there is you can log that. You can send it to Crashlytics, to any of your logging solutions, to be able to say, oh, actually, I wasn't expecting in the user flow that this code called actually the camera. Maybe you wrote some wrong code, or maybe there is a part of your code that did it and you weren't even aware. So that's really good. And we're bringing that for all developers on Android 11. So that was the data access API. So now we'll go to the new foreground service types. So we already saw a lot, but there is still more for developers and users. To provide better accountability for apps to access private data in the foreground service, we've added a couple of new foreground service types values, microphone and camera. So on Android 10, we introduced the concept of the foreground service types. All of those services, the idea there is they're accessing a specific private part of the device, and they need to be highlighted to the user. So whenever you use one of those services, you will have an active notification that the user can't remove, except, of course, if they close that service. So it's just to bring more transparency. If an application is using location actively, is syncing, is being a media player, media projection, a companion device, or just simply a phone call, you should be able to know that as a user. So that was already the case on Android 10. And media projection and location, they were enforced to ensure accountability for access. So others were recommended, but only 2 were enforced. So now on Android R, if you target Android R, to be able to access the camera, you will have to add the foreground service types attribute in your XML. And the same thing for microphone, and you can actually combine both of them together. So again, here, the idea is to recap. On Android 11, if you need to use a foreground service to access any of this data, you must declare the corresponding foreground service types in the manifest. More accountability, better transparency to users, like that it's clear when any apps is accessing one of their private data sensors. And it's also good for users to be able to know which application is actually using my location rather than having to delete or close all of them. Now going to package visibility. Let's talk about those changes there. So on Android 10 and older, so before Android 10, Package Manager get installed packages with 0 as the default value, allows any apps to check all the installed apps on the device. And that was used for so many ways. The main thing was mainly to propose proper integration. For example, in your app, you want to open directly a YouTube link with a YouTube app. You have to check if the YouTube app is installed, and you will open directly YouTube. Same thing with Google Maps, with Google News, any other Google services, as well as third-party apps. But for privacy reasons, it's definitely clear that there was some abuse, and also we should be transparent which application we actually need to check if it's installed. So when you target Android R, so Android 11, sorry, API R, to provide better accountability for access to installed apps on a device, Android 11 includes some changes to how apps can query and interact with other apps. So for several common scenarios, you actually don't need to make any changes. And let's have a look on that. So if you're querying through the package manager, as you always did, you may just have to change some parts of your XML, or if you're just accessing some specific apps, you don't even have to change anything. But again, let me show you with more code. If you target Android 11, get package info with your own package name, so your own application, it will still work as expected, no problem there. And if you get installed packages by default, so you don't ask anything, you don't add anything to your manifest file, you will have access to your app as well as the system packages, so the one which are core Android functionalities. Those will be the one you will have access to. It doesn't mean the preloaded application from third parties will be visible. Only the core Android functionality apps will be visible. And let's say you want to have your own share sheet. I actually advise and recommend to just use the default share sheet, which is just launching an intent with the right action type. It's still highly preferred than creating your own custom one. But if you have a specific integration you want to show and want to be able to capture an image with a camera application on a device, for an implicit intent, you don't actually have to change something, because the implicit intent will just show the dialogue the recommended way, and that will just work with no change for you. And you will have the result automatically because, again, it's handled by the system. You don't have to create your own UI. But in the case you want to check, let's say for a specific app, I want to check if Google News is there. By default, if you don't change your manifest, and I will explain how we can add that to the manifest, you will have an exception named not found exception, even though that application may exist. Again, it's here for privacy reasons. By default, you should just not be able to access everything. But if I want to check if another .app exists, I will have to add a package node property inside the queries tag in my manifest. So here I will have to list all the applications that I want to check. In this case, I want to check all the applications created by my own company. Like that, we can propose a really nice integration between them. And you can add more packages, obviously, in that manifest. Now, in the case you want to be able to target all the applications that can handle sharing an image. Here, trying to get that from the Play Store, there may be thousands, if not even millions of applications that can share images. So it's just so hard to list all of them. In this case, what is recommended instead is to use this action property where you put the name of the intent that you want the application that can handle it. And you can even be more precise here and say, I just want the apps that can handle sharing an image which has this specific MIME type. We can add obviously more MIME types like image/star to get all the images, all the application that can share images and not specifically the JPG. And here, still, you just use get installed packages, so the API doesn't change. It's just how restricted is your view or not. So here in this case, it's much better than just adding specific applications, because not only Google Photo can share images, other apps can handle that, and you may want to be able to provide that integration in your app. And in practice, we found that most applications can easily express necessary package interaction with intent and package declarations. But we still added a specific permission, which is query all packages. So when you add this permission, you will be able to access all the packages. But because it's so privacy sensitive, you will have a review made by the Google Play team. So it doesn't mean that it's an automatic permission. You won't have it until you're getting reviewed. And there is obviously some Google Play policy to explain which cases can be handled. So if you're an antivirus, or we listed on our documentation the kind of use cases you can handle or not, but I highly recommend you to not use it and just use the queries with action and package properties instead, because it's more privacy transparent, it's more precise, and it just avoids you to have a review because you asked for query all packages. And so, it's not because you have to explain deeply why you need this permission. It's not an open permission, it's special permission, similar to the SMS permission since Android 10. So sometimes if a social map, a point of interest map app fires a view intent with certain URL, you may want to be able to take users directly to the default native app that can handle the URL. And we know a lot of people want to check the list of installed apps because by default, users may get that dialog box, and maybe you just want to have a faster interaction, a better user experience. So by default, that will show this dialog, as you know. But in this case, I know for sure I just want to open Google News. I just don't want to open a browser. I just want to open the native app that can handle it. So that's why we're adding a new flag, which is flag activity require non-browser. What does that mean? Is in the same way you were opening intents before, in this case, if there is a native application that is not a browser, so Google News, the native app, YouTube, the native app, or third-party native app, which is not recognized as a browser, it will open it directly without having to show that dialog box. Or at least it will filter out all the browsers and have much better interfaces for you. And in the case there is no apps, so you will have an activity not found exception. It means only browsers can handle that specific URL, for example. You can still open it in a Chrome tab, in a custom Chrome tab, so the one that integrates in your app, so still provide a better experience, more integrated in your vision of user experience. So again, if no default native apps, you will have that exception raising. The important thing there is maybe you want to be able to test that, because obviously it's hard to just create constantly emulators and disabling it. So rather than doing that, you can just with ADB enable or not package visibility with your app and be able to test it. You can even check in your logs if a query has been blocked or not, like that you have the proper view and testing, helping you improving the compatibility with Android 11. So that was also a lot. Now let's go into scope storage. I'm going to do an overview, and after that, obviously, you will have a more deep dive talk from the next speakers. So for the ones who didn't properly follow scope storage on Android 10, we introduced scope storage as a way to help classifying the way users handle different types of files. So before, they were just read external storage or write external storage, and it was just like a wild access to the SD card or the internal shared system files. So it was a bit like it was a bit of clutter, and it was not clear because whenever you interact adding a file, an image, etc., this file wasn't attached to you. So whenever users were complaining a specific app was adding a lot of images, if they still go in the settings, it will just show the app size with obviously the app data, but not any files created, media files created by that application. So on Android 10, the goal is a better attribution. Whenever an application is adding content, we can track it, so we can show it. This application added 5 GB or 2 GB of data in the device storage. Better protect app data, like that it's clear no one can access your own data, everything is properly separated. And also protect user data. Maybe in some cases, application may just want to access media files, or in the other case, accessing non-media files. They should better use storage access framework. So here the goal is really to make sure that rather than having a wild access, you have a precise access. Like that, you will also have way less refusal from users, because maybe a simple social media app asking for wild access to storage may be a bit awkward for some users. So here, at least you are having a more precise permission. So here are the specific storage changes we added in Android 10. So unrestricted media and downloads contribution. You can create files, so create any media files and add them in those collections without even having to ask the permission. So that's already a huge benefit. You can add them, you can delete them and edit them without having to ask permission, because those files were created by your application. Only media collections can be read with the storage permission. Here it's to make sure that when you're asking storage access, you should just get what you actually need rather than wide access. Location metadata requires permissions. So on all the files that may have location data, so whenever you take a photo, maybe there is some location data attached to it, we will remove it on the fly, making sure that when a user share an image to or open an image with a third-party application, if they don't ask for location access, they should not be able to get this kind of information that can help them to infer where the user actually is. And we have the system picker for all other file types that existed from Android KitKat. So the storage access framework allows you to use a system view to access any files, and that's still there, and it's the more recommended way if any of the applications are requiring any media files or non-media files. So rather than having to create your own UI, you can just use that. And reading or writing outside of collections require this system picker, again, to provide better accountability. That was enforced by Target SDK, and there was an option to opt out because maybe the migration may take longer with a request legacy external storage manifest attribute. So on Android 11, we improved upon scope storage in a number of ways. We will have a look together. First, we made further adjustment to storage permissions. Storage renamed to files and media. So when the permission will come to the user, it's more clear what they will access to. And with Target SDK version R, write external storage and write media storage do not grant any additional write access. So you can add it, but it won't change. You just need to have read external storage here, so you know, like that there is not like a special permission for handling something different. Also, the other thing, we heard the feedback from users as well as developers. We're bringing the constant UI for bulk edits. Before, on Android 10, if you needed to edit a media file that was created by another application, you will have a dialog that will be coming to the user, but you can only handle one file at a time. Now you can handle multiple files. You just need to create a write or delete request for that. You can also designate some media as favorite. So you can label some media files as favorite, and in the native, in the default gallery of the user's device, there would be a favorite collection, and those favorite labeled files will appear there. You can also put media file into trash, and the difference there is the trash, rather than deleting them, will put them basically in the trash for 30 days. So if for anything the user want to restore them, he or she has 30 days to do so. Also, your app can do that too. And after that, they will be deleted automatically. Okay, so in terms of code for MediaStore API and bulk edit access, you will have to create MediaStore.create write request with a content resolver and the list of the content URIs you want to edit or delete. So there is create write request and create delete request, if I don't say mistake. And after that, again, you just handle it like any intent. You will have this UI coming up, so you don't have to handle anything in terms of UI. It's transparent to the user. And after that, granted or not, you will be able to access those files or not, depending on the result. We're bringing some restrictions on the action open document tree intent. So this is the storage access framework, the native UI showing to the user. You won't be able to access any folder from the which is the root. You can't ask for the root directly. You can ask a precise directory, but not the root. The downloads directory also, because we saw that a lot of users have been dropping a lot of sensitive files. When you go inside, you can select any files or any subfolders, but you won't be able to ask the whole downloads folder. And obviously, Android/data and Android/OBB won't be accessible too. So the user won't be able to select grant access when it goes inside. For action open document, you can open any document within the root, within download, but not within Android/data or Android/OBB, because again, those are internal storage for application, so they should be separated. One other big thing we introduced with Android 11 to simplify your migration to scope storage is we brought a file path access. So maybe you have been using the file path, the file API from Java and Kotlin. You've been really used to and comfortable with. Same thing if you used through the NDK. And one thing what we did there is with Fuse, a virtual file system, you will be able to use that same API. Underneath is still the MediaStore API. So if you want the raw true performances, you just use the MediaStore API. But if your code relies a lot on the file API, you can just use that file path access. It won't give you more access. So basically, all the restricted view you have on MediaStore will be translated with that file path access. You don't need to enable anything. You can just use the file API like you did before. And the MediaStore enforcement are maintained because now we're giving you other APIs to be able to enjoy scope storage. So again, as you know, Fuse is a virtual file system, so it's not directly the file system. So there isn't an impact in terms of performances. Based on our tests, it's expensive for open and first reads. So if you keep reading after that sequentially, there is no problem. But if you do some random read, there may be an impact in terms of performances. So again, if you want the best performances, just use the MediaStore API. And we still know that some application may need a way to be able to access the whole user's storage on a device. For example, File Manager, but also maybe some backup and restore, or some productivity app that makes really heavy usage of storage. So on this case, they can use the Manage External Storage Permission, a new permission we're introducing in Android 11. But the thing you have to know is it's a special permission in the same way I mentioned earlier, query all packages and SMS permission in Android 10. So your app will have to go through a review by the Google Play team, and there will be some guidelines to highlight which use case are accepted or not. So if you just want to have a custom UI to select a file, you won't be able to get that permission. We just highly recommend you, and to be honest, it's the only way now, to use the storage access framework with Action Open Document or Action Open Document Tree. But if you have one of those special cases, you will be able to access that permission. And the thing to know is it's a special app access. So first it has to be reviewed by the Google Play team, as well as it will open directly the settings. So it's not just a dialog on top of your app. The users will be sent to the setting to allow it or not. So I know I'm a bit over time. I'm really sorry. I just have a few slides left, but still some important changes related to privacy on Android 11. So one thing we find out is a lot of application needed to check the read phone state permission to be able to provide a better user experience to check if the phone is actually ringing or idle in terms of states. But knowing the actual phone number which is attached to the SIM card is something that most applications don't need. So on Android 11, we're separating those. Read phone state will allow you to get the state of the phone, so knowing if it's ringing or idle. I think it makes sense a lot. Makes sense for a voice application, for example. But if you actually need to get the phone numbers attached to the device, so you will be able to call read phone numbers permission. So it's a new separate permission, and it's only available if you target Android R. And also, obviously, to make sure you have the backward compatibility, you can just set a max SDK version until 29 for read phone state, and after that, adding the read phone numbers, which is only recognized, obviously, in Android 11. On MAC addresses, you won't be able to get them directly because we think those are really sensitive information, and they would be randomized from Android 10 already. If you connect to a different Wi-Fi network, they always change to make sure the privacy of the user is kept. Some more details are there. I think for the ones who are really having a heavy usage in terms of network, can get more of an idea. And we also have all that changes highlighted on our documentation. So you can check MAC address restrictions on our documentation to get more details. And the last one is you won't be able to draw something on top of a current UI. So your app can't draw on top of another UI if you don't have a special permission, which is the action manage overlay permission. Because before we saw that it's a really common way to show, for example, current chats happening. And for that, we highly recommend to use the Bubble API. You can check my colleague's chat he made a video about it on our Medium blog post. But for application, they will have to request it because it's not directly available for them. Preloaded apps are still granted by default, but installed apps through the Play Store won't be able to get it automatically. So thank you very much. I know I've been a bit over time. I'm 47 minutes now, so sorry for taking over. But the next speakers are as good, if not even better than me. I highly recommend you to stay. And I think we'll have also questions. I don't know if it's just after me or after all the talks.
Yeah, we still have questions. Yes, I will ask you right now.
Okay, perfect.
Yeah, thank you, Yasin. It was super impressive. Yes, so many changes. I hope that Google, starting from Android 7, I remember that Google started adding some small details about security more and more, and now we see so many changes in the security and privacy. And I hope that Google will continue focusing on confidentiality and security and privacy and all this stuff, because it's super important. I remember the time when many years ago, a lot of people were yelling that Android is not so secured. iOS, yes, Android is not. So, but right now I see that so many things got changed, and it's starting more and more secured, and it's really looks very solid. Secure is solid. Yeah. Okay. So let's focus on the questions. And the first question from Dennis. So he said that it's quite hard to explain to user why for scanning BLE by beacons I need to access device location. why not to make more granular and self-explained permissions?
So when you're doing BLE beacons, accessing scanning for Bluetooth beacons, those can be used because those Bluetooth beacons, if I don't say mistake, they can have like a unique ID. So if you know you have been next to that one precisely, which is installed, for example, in London next to Big Ben, you know the user have been next to Big Ben, which means you can pinpoint the user's location. So that's why you need to give context, because otherwise you can get the user's location through another way, and we think we need to be transparent. A bit related to that, there is I forgot the name of it in detail, but with Apple we partnered and we introduced an API especially for government and public health institutes to be able to create application which can help contact tracing systems related to the COVID-19 pandemic currently. And one thing we did with that new API is, because it uses all the Bluetooth to be able to check if a person has been next to you, and after that, that person can self-claim that they have the virus or not. You can only use it without having access to the location. Because for this case precisely, again, as we know, we can identify through with Bluetooth beacons, we can know the location. Here we made a way that you can figure out if you have been connected with another person's, with another device, without having actually getting the actual unique ID of that Bluetooth device, so still protecting privacy and not showing the user location. So for governments and health institutes who want to use it, they won't be able to request the user's location, again, to protect the user's privacy. That's why we're making it harder, because it has a huge impact in terms of privacy of users. If you need, you just need to explain that flow to the users, certainly with an animation, for example.
Yeah, that's true. Okay. So the next question from Shaba, is the reason for the MAC address and network restrictions driven by making Trojans work harder?
I don't know all the reasons, but I remember, for example, on Android 10, they made it harder to get, for example, on Android 10, so Android 10 and further, we randomize the MAC address whenever you connect to a different Wi-Fi network. And one thing is the Wi-Fi network on some shops, some businesses, they were making sure to identify through the MAC address if a person have been there. So if they have been to that store and they have been to another store or another business, they know that person have been traveling that way. So by randomizing it, you can't fingerprint them. So again, to protect users' privacy. So the further restrictions, I don't know all the details, but I'm pretty sure it might be related to security as well as privacy.
Okay, I got you. So, and the next question from Abhishek, do you think the Android file management is going towards iOS type?
I'm not fully aware of how it works on iOS, but here, basically what we're trying to do is we're making sure that the file API, so the Java file API, or the same one that you can use through the NDK, is still preserved, but we still need to balance that with the fact that users have so much private data there that you actually you want to make sure not every application have access to that. So we're trying to find a balance, how to make it easy for developers, as well as preserving the users' privacy. We still have some concept that I'm not sure if there is on iOS. I don't want to go further because I'm not 100% sure how it works on iOS. So I don't want to say a mistake, but we're trying to find the right balance there. And that's why we keep improving there on each Android versions.
Okay. Yeah. Okay, and the next question, I think that one or two more questions, and then we continue, because we need other speakers are waiting for us as well. So if the Google Play flagging excessive access to Wi-Fi scan, we use fused location and active recognition. Can I get more granularity of usage via audit API? You know, there is also a similar question from Dennis about the read phone state access to serial number. For example, when as a developer, he understands why he needs, but as a user, it's quite hard to explain that. So in this case.
In this case specifically, I don't think accessing the activity recognition will get you any usage. So the callback getting called through the audit API. Fused location, I think, if I don't say mistake, but the activity recognition is not yet. I don't know if in the future it will be, but currently it's not there. So fused location, yeah. And again, I highly recommend you to, in the same way you log whenever the user may be online or not, you should log also when you're accessing those data, and the audit API allows you to do that really simply. Like that, if you have any problem, you can make sure that, oh, I wasn't aware that this part of my code was actually calling that. Because the thing is, we have the feature tagging as I highlighted, but you can still throw like an exception to get the stack trace. So you can send that stack trace and know precisely which part of your code actually called it. Like that, you know for sure where this happened. Maybe it's a library, or maybe it's an SDK you have been using and you didn't even know that I've been doing that, for example. So yeah, for fused location, have a look.
Okay, yeah, we have so many questions about the granularity of the permissions. So another question from Alex, there was a feature request to granular access to contacts. Any news about that? You know?
If we don't have something, I don't know personally if there is, but if it hasn't been announced, it's still not there, I will say.
Okay.
There may be some plans and I'm not aware, or if I'm aware, I can't say. But in that case, really, I just don't know, because it's not an area I work on. So I think for all of you, just so you know, Android is just so big, so large, it's hard to know everything. So in my case, I focus on some areas. That area, I don't cover it yet. I should do.
Yeah. And my personal question to you, we'll end up with the questions. And my personal question to you: what's your favorite feature in the latest release of Android 11 in privacy or in security?
So I chose to focus on privacy because I think it's really important. I've been seeing a lot how many people have concerns now about their own privacy being used or not by apps. I don't think it's a case of stopping interactions. Like, everything should be open and usable on Android. It's just we need to be transparent about it. So having more foreground service types, I know for sure when an application is using my camera or my microphone. Location was already the case on Android 10, but I think I'm a really big fan of the one-time permission, because so many apps, I feel they don't deserve it all the time. So it would be perfect to just give it when they need it, which is great, because it still means for them they will access to the sensor. It will not break them, but giving it all the time, actually, I'm not sure I would like to do that. So it's perfect.
Yeah, thank you, Yasin. It was very informative. So many things got changed, and you covered lots of things here. Thank you very much for a great material, great presentation. Thank you very much.
Thank you for having me.
Yeah, sure. Okay, so right now I will invite the second speaker. Okay, the second speaker, Vadzim. Let me invite you. Yeah, Vadzim, here is you.
Nice to be here again.
So, and yeah, nice to be here again. Okay, so Vadzim will tell us more about the location permissions and everything. I see the request about making the presentation for the next speaker larger. So it means that you will see only the presentation, not the speaker. If it is okay, what do you think?
I'm okay with it.
Okay. So I will change the layout for you. So please, okay, I will remove myself and leave you alone in just a second.
I'm going to continue talking about privacy and Android 11. I won't introduce any new features for you because Yasin did a really great overview of all the privacy changes. It was really great. Features more in deep to talk about some use cases, some edge cases, and maybe more code examples. My name is Vadzim Vysotsky. I'm Android developer at Godel Technologies, and I'm also part of Android Academy Minsk organization team. When I was preparing for this talk, I created a test project to play with the new API, and it's already available on the GitHub. You can download it and play with it as well. And of course, you will need an Android 11 emulator. And if you'd like to continue explore Android 11 features, you will need a lot of information resources because source code isn't available right now. So all my statements is based on documentation and information from different sources from Google, and of course on my personal experience. So let's start exploring together. I tend to agree that one-time permission feature is really the best in Android 11. At least it's a favorite for me. I really like it. Let's recap how it works. If we compare permission dialog of Android 11 and Android 10, you can see that Android 11 provides one more possible option, is only this time. How it works: when when application requests a location or microphone or camera permission, operation system shows you a dialog with the only one-time option, and if user selected, permission will be granted, but not forever, only while application is visible. So now we're ready to the most interesting part. What happens when? Let's talk about some edge cases. We will start with a simple scenario. For example, preconditions are following. Application has just got one-time location permission, and sorry, it looks like something wrong. Oh, yeah, you can see it again. Cool. Application has just got one-time location permission, and then user hide it, basically switching to the launcher, and then open it again. It was one-time permission. So tell me, what is your expectation in this case? Maybe permission will be still granted or it will be revoked. Please reply in the chat. What do you think? How do you expect it to work? How would you want it to work?
It's a super tricky question, I would say.
Yep. Because as a user, I see that I gave permission only for one time and I don't see any activities anymore, and there is no foreground service.
So everyone, what do you think? Yeah.
You can just type in chat plus or minus. Like plus means that permission will be given, and minus means that it will be revoked. We'll wait for another few seconds to let you answer. I see. Nice to see different opinions. And correct answer that location permission will be still available for your application if you make everything quickly enough. Cool. Let's consider a little bit more complex example. What will happen? Preconditions are the same. Application has just got one-time location permission, and then user switch to the application list, swipe up your application, that is basically kills the process. Then user goes to the launcher and open your application again. And now the same question. When application opens again, will permission be granted or revoked? What do you think? Again, reply in the chat. No
I
foreground
will.
service. Yep.
I will guess. I guess it's very depends on device manufacturer.
It's Android 11 is in beta version. Maybe everything will change a lot. So we're talking about how it works right now. Waiting just a few more seconds to think and answer.
There's a lot of minus revoked.
Yep. And I think that permission will be revoked, but it appears that it's still granted. But again, it will be granted only if you make everything quickly enough. So how to lose one-time permission? And you need a little bit of patience. For example, if you get one-time permission and switch to the other app or just hide your application for some time, like for example, 1 minute, then when you get back, permission will be revoked. So did I say minutes? Yes, but don't concentrate much on specific number because documentation clearly says that it's some time. And according to some podcasts with Android developers, they said that it's not hard-coded number in framework code. It's something dynamic because Google want to test how different number works and adjust this number in future. So right now it's about 52 seconds, but it definitely will be changed. Just to recap, Android revokes permission when some time is passed. So it's not related to process lifecycle. It relates to application visibility change. So when application not visible for user and some time is passed, then Android revokes a permission. And the next question arises. How to handle permission revocation. Actually, we should think about this before because user could go to the settings and just revoke permission manually. But with Android 11, it became more common case because now revocation permission is semi-automatic. Sometimes Android revokes permission to help user keep his private data. Let's see some example. Somewhere in your code, you can check that you have some runtime permission. And if you have it, for example, you have some asynchronous calculation, some logic. In my super simple example, is just 15 seconds delay. In theory, this time is enough for user to go to settings and to manually revoke permission. And the question is, what should we do after this delay if we want to get some private data again with the same permission? Like, how should we handle this possible permission revocation? And I have a good news for you because in Android, permission revocation handling is straightforward because whenever some permission is revoked, Android kills the process of your application. It's really easy to handle. You basically don't need to do anything. And despite this fact is well known among Android developers, it's strange that it isn't documented anywhere. So in your application, you can expect that if process was live, so we can get to this point of execution only if process is still alive. So we can expect that all the runtime permission that we got before is still there, because otherwise process would be killed. Like your lifecycle events of activities, fragments, wherever is a good place to check if permission was revoked. But you know, all these insights about time and how it works under the hood doesn't really matter when you use permission best practices, because according to best practices, you should be always ready to ask user for permission. And what is also important aspect of best practice of permissions best practices is to respect user choice. You know, even this release has letter R, which I guess means respect, because Android 11 helps user get this respect from developer. Let's see what changed in deny button. We will check it by comparing the same scenario for Android 10 and Android 11. We will in-cycle request permission and reject it, request and reject it, and we'll see what happens. We request permission for the first time, get permission dialog, deny it for both applications. Application permission isn't granted, that's fair enough. Request permission again. At the second attempt, you may notice that there is one more option at Android 10, deny and don't ask again, that is not present in Android 11. But anyway, we won't use it. We will hit deny one more time and request permission again. And on this time, we get permission dialog only for Android 10. And it's because Android 11 considers two denies as don't ask again automatically. So this is one more point to why we should use API should show request permission rational, because it's a good chance for us. We can explain to the user why do we need this personal data. Maybe we will convince user this time, but if user still isn't convinced, he can deny our request in our custom UI. So if in some future he will change his mind, or there is some other features that so user will be okay to share personal data because of some other features of our application, we won't have to push user to settings. We can just show permission dialog one more time. Cool. We just talked about how to get permissions. And one more very important point is to how use this private data inside our application. For this, Android provides us a really cool feature that is data access auditing. And we already hear about it, but I want to highlight this fact that auditing is about understanding how private data is used inside the application. And this understanding is basically the first step in any troubleshooting and in any improvements for your application. When you understand how you use it, you can change it and improve. Let's recap. How does audition look like? Auditing look like? So we can set up a special callback of 3 events: on noted, on self-noted, on async noted. We can set up this callback in AppOps Manager, and so that whenever application access some private data using any system API that could be resolved from the regular context or from our own attribution context, one of the callbacks will be triggered. And we can analyze data about data access, about private data access, and track which data we use and how we use. For example, if we log all the available data, we can see that somewhere in our application was access to user location. It happened using our attribution context, and attribution text is example. And we can easily track the place where it happened by analyzing stack trace. As on noted is synchronous await, we can just create a throwable and check stack trace, and as you can see, it's straightforward to guess that access to the private data was inside update location function that is called from main activity. attribution tag that you saw before is really useful for separation. We can separate different feature from each other. We can separate our application and different third-party dependencies. Let's consider some example. In this simple example, we will think that all the third-party dependencies won't use any attribution tag. So we log these private data usages as an error to highlight it in output, and regular data access we will log in the debug output. And for example, you decided that you need to improve your button appearance. You don't want to implement something manually. You just look for some library on the GitHub. You found it. You see that there is a cool description. It's a lot of stars on the GitHub. It's open source code. You just basically happy. You add one more line to your Gradle dependency, and you start using this library API. Don't focus on API, it's just an example. In my case, I just set up a different button appearance. If permission granted, we use one style. If it's not granted, there is another style. You launch application, everybody happy because buttons look really good, but terrible things are happening in a while. If you take a look on error output in the logcat, you will see that there was some data access and you don't know where it's from. Let's try to trace it. This was logged in on async noted event. We can see that it was accessed to user location. We see that time when access happened. But anyway, it's not really useful in our investigation. And what is really useful is message. Message provides us some additional information about data access. In case of location access, it provides system identity hash of the listener and its hash code. So system identity hash contains class name, so we can easily track where it's listener. And our clue leads to the cool button library. So as you can see, data access auditing can help you understand what is going on inside your application, because it's hard to keep everything under control and constant monitoring and reviewing all the code that you connect to your application. And one more interesting question, what private data is from the auditing point of view? Like, when should we expect all the callbacks to happen? To answer this question, we need to dig a little bit deeper inside the Android framework. There is something called AppOps Manager that is responsible for tracking and allowing or denying access to some private data. For example, when some other framework part, like Location Manager Service, want to know is process that requests some data eligible to work with location, it asks AppOps Manager about access by calling node op function and pass op find location as an operation that it want to do. And AppOps Manager allows or denies access to the data. And every time any part of Android framework asks AppOps Manager about data access, one of the callbacks is triggered. So to understand which data access triggers callback, we need to check what kind of operation does AppOps Manager support. And there is quite a lot of them. It's 90 operation types, at least in Android 10. But callbacks aren't guaranteed to be triggered for all the data access operations. Documentation says that it's guaranteed to be triggered only for data access related to some one-time permission and maybe for some other data accesses. So if we highlight only related to one-time permission, it's not so many. But we still can get a callback for any gray out event. It's just not guaranteed. Maybe final decision isn't made yet. And just before I finish, I'd like to say a few words about Android 11 privacy. I'm really excited to see what is going on with Android over the time, how operation system cares more and more about user privacy, and I wish Google to continue enforce all these rules. Thank you for your attention. I hope you enjoy this talk.
Yeah, Vadzim, hello.
Hello again.
Yeah, you did it. Yeah, we are waiting for your questions. Please write your questions directly in the chat, so we can discuss it. While you're singing or typing your questions in the chat, I can tell you, Vadim, that it was really insightful. I think that those tricky questions about the process desk and everything, revoke permissions, it was nice idea how to check whether we are ready for those features, or I would say features or actions. I don't know. So yeah, for me, sometimes it's surprising to see such I don't know how it handled underneath in the Android framework. So okay, I would like to ask you a question about this auto reset feature, about auto reset functionality. Is it possible to know whether it's disabled for my application?
Asking about one-time permission.
Yeah.
Yep. It will be enabled for everyone, I guess.
Mm-hmm.
So even if you target a API before the Android 11, it still will be applied for your application. And I think it's a right choice from Google.
Yeah, that's true. But I mean, this auto reset permission for when you do not use your application, the Android framework will revoke several permissions from the application, right? So I mean, do we have any possibility how we can check whether this functionality is disabled for our application or not?
There is just a special API that you can check in, and it replies you with the answer, like, is it enabled or not? Because some application really need to ask user to disable auto permission revocation. There is some cases like application related to IoT devices, for example, which just want to track your location, and you basically don't need to open it. You can always use it without opening it because it's always in the background. So for cases like this, it's okay to switch off.
Okay. Yeah, we have one question from Dmitry, and he asks, will access audit log be available to app developer or to user as well?
It will available for developers because it's just a new API, and if you log it to Logcat, for example, probably your user will see it too if they know how to use it. Actually, its primary target is developers, just to let us know what is going on in our application. Maybe in future.
Yeah, very useful API. I think sometimes it should help us as developers to know. Yeah, great, good. Okay. I think that we can continue then. If you have if someone has any questions, So you can continue asking it in the chat. So Vadzim will be with us, so he can answer you. So yeah, we
Thank
can.
you very much. It was nice to be here.
Yeah, Vadzim. Thank you for your good presentation. It was really informative as well as Yasin. So, okay. So yeah, Jonathan, where are you? Yeah, here are you. Okay, Vadzim. I will remove Vadzim from our topic. And okay, so we continue with Jonathan, right? Jonathan, are you ready? Are you ready for some action?
Yeah, was
Yeah.
born ready. Kind
Yeah.
of.
Kind of.
Still not sure how it's going to be, but let's try. So
yeah, it should be. It should be good. Okay.
yeah, hope so. Hope so.
Yeah, I'll leave you alone. So
No, please
sorry.
don't. No, no, no. Hey. They left me. Okay. So let me switch to the presentation. So for who don't know me, my name is Jonathan, or Yoni. My friends call me Yoni. I'm doing in my life a couple things. One of them, I'm leading a Android team in a fast-growing startup called Monday.com. And also I'm a part of Android Academy of a global team. Here, if you want to add me to the Twitter or Facebook, feel welcome. Just don't nag me. Couple words about Monday. It's very fast-growing startup. Small companies like Tesla, IBM, Intel, Pepsi, and others are using us. So thinking we're doing a great job. A couple words about Android Academy. For who don't know, we are like the largest Android community in the world by far. So today we are operating in 4 different cities with one goal: to give everyone the access to the knowledge, to learn for free, to meet new persons, network, build your career, and become the better version of yourself. So feel free to join, to come to our meetups. If it's online, we'll go back to the offline as well. So what we're going to talk about today. And maybe before we start this talk, actually, I will give you some background. So I used to work with files long time ago. For me, it was always like the black box, like, yeah, there's a file. So I put some name, create, and that's it, over. And then actually, the reason why I took this presentation to prepare it is because I had zero confidence and knowledge in how all this storage working on Android. So I really wanted to deep dive in that. So it's kind of like new to me. I did a lot of research, and we also implemented in Monday. So I learned also from those examples, and I will share these tips. So we're going to talk about like files one-on-one, like how it works, internal storage, how you create files, how you open. Then we will dig in different type of storage, like internal, external, and then we will talk about the new shiny thing called Media Store API that was announced in Android 11, and also we will talk about the SAF, and I will share with you tips from production that are gathered from our experience in Monday.com and also from other folks in the industry. And first of all, I think need to understand that security is hard. So all these changes, like I talk with my friends, and all of them say, hey, like all these changes about the storage is a big mess, and it's going to hurt a lot of users. And the fact is that security is always comes with a compromise on usability, right? So you sacrifice something from the usability, from perspective of the users, to gain more security, and it's always the trade-off. And we need to take this into account and come to this mission to migrate our storage usage to new shiny APIs in the new security way, with a grain of salt that we are going to think that important for the users, to save them from malicious app and excessive different storages that they shouldn't be accessed. So I think that most of you are familiar with this dialogue. That you install some app that someone recommended, or say, hey, there is a WhatsApp new thing that get you access to new features that that not exist in the original one, and then you're asked for the permissions to read all your data on the device. And actually, you never know which data it access. You never know what this app is actually doing with your data, with your files. Maybe there is some important photos of your family, or there is a screenshot of your bank account and all that stuff. So it's kind of like dark mess. And there's a lot of other malicious apps that Google constantly trying to protect us from them. They remove them from the Play Store. But it's kind of like sheriff and bandit story, that there's one sheriff, but there's a lot of bandits and a lot of gangs, and it's like very hard to win in that. And one of the very popular stories that there is Cam Scanner, very popular app that actually there were malware inside the app that was scanning the storage for data for the files, and were uploading somewhere, and actually the app was very popular, so it's affected millions and millions of the users. So the whole story is very important. Until today, we have the Wild West of the storage. And besides that there's a Wild West, and there's no any sheriff in town. There is a problem with the storage, so that you install the app, you use it, it saves some data, and then you uninstall it, and it's leaving a lot of garbage after it, because the files are never removed, and there's no control unified. So Google doing a lot of things to improve on that. And there's a lot of changes that coming in Android 11 to force us developers to adopt the new changes, even if it's hard, even if it requires more work, but it's something that we need to do. And there's a clear time frame of when and how we should do that. So I think most of us familiar with the mean decay, targeted mean targeted decay that we need to support. So starting from the August 2020, all new apps should target 110, and then in November, all apps, it doesn't matter it's new or it's update, should be target 10. So you can use still the legacy storage flag in the manifest, but very soon in August 2021, we will have forced to target the 111, and we need to take it into account, and we need to prepare, and we need to work to plan how we migrate all our storage into the new API test. So the changes are here, and this is the talk that should help you to prepare yourself for the new changes and to understand them more. So to understand more, it's always good to start with basics. Maybe some people don't know. So how we access the storage? So we have this basic flag in manifest, uses permission, read external storage. We access for the runtime permission, and the user see dialogues of allowing or denying the permission. And basically what it's allowed up till today, so we can take this snippet, we can go to some place in any place in the device, like some other app, private photos from this app, and then we can take this directory, take all files that are listed, and go one by one, and just to create just to read the content from it and store it or upload it to some other place. And it actually kind of what we have today, and starting from Android 11, it's actually become a security exception. You will not be allowed to do it anymore. You will not allow to access other apps' private storage, and means you need to also to adapt how you work with your files in your application. And there is a couple types of storage that allow you to do that. So let's start with the basic, the first one. So there's a internal/cache storage. So basically, it's your app internal storage is stored in your root directory of your app. Is actually no one, if once you're targeting to 110 or 11, no other app can access this storage. You can work freely with the file API. There is like also cache. It's the difference between internal and the cache is that internal, it's stored in the device and then it's deleted when the app is deleted, and actually it stays within the app storage till the app itself is deleted. Cache is something that if the system will demand for more space, this is the storage that we're going to be deleted. So it's kind of like temporary storage that we can throw all garbage there, and the system, once they will need the storage, it's automatically going to be deleted. And the cool thing about that actually you don't need any permission to access internal or internal storage. You can freely write it as much how much as you can, and if you want, and it works perfectly with a Java Files API without any changes. So basically, the usage API is very simple. You have files dir in the context API. It's actually this is the path to your root folder in app storage. So you can, like, for example, here I create the file Marvel is awesome, and then actually I write into the file using the output stream. It's very important. I mean that don't use hard-coded paths. Like, yeah, we all know that most of the time there is data slash package name, and then you can access it, but it's not consistent between the devices. So better to use files dir variable in the context to get the path to your internal storage. There is actually in Kotlin there is a short version of opening output file. So basically, you can, on the context, you can use open file output, specify the name of the file, what mode you're using. You're mostly going to use mode private, and then actually you can get all access to the file inside the internal storage, and you can write it easily. By the way, I used here trick from Kotlin called use. So basically, when you work with APIs with a file, so there is like always important to close the file, to close the stream, etc. So use is kind of take care of it by itself. So basically, for you, it's just one single method. Cool. To read the storage is basically the same. So you can take the file and actually use the input stream and actually to read the bytes from the file itself. And there's also the short version, like on the context, open file input to specify the name of the file, and that's it. You're good to go. Just read the bytes and do something with them. To get all the files in the directory, so it's also like you go to the files dir, you get the path, and you call list files, and then you can just go freely over the files. Actually, and for the cache, there's almost no difference. Just you're using cache dir instead of files dir, and you're good to go. The API is same, and the usage is the same. Cool. So we have the internal storage. So what's about the external app storage? So there's some misunderstanding between external storage and external app storage. So external app storage is actually, as it sounds, it's your private app storage that's stored external from the private package. It can be stored on the SD card, right? So there is I think it's mostly on the old devices or devices that's still using the SD card as extension. So basically, external storage is going to be stored on external storage in SD card. On some devices, like for example, in Pixel, where there's no SD card, there is partition inside the physical storage, and they actually are allocated for external storage and internal storage. And also, it can be mixed, both of them. It can be physical allocation of external storage on the device itself, and also on the SD card. So one important thing is actually that you have, it's called volumes, all kind of different storages you can use to store your files. It's like literally all kind of. So I suggest you just to use, instead of using paths and search for correct volume, just use get external files dirs on context, and you will get the correct directory, or external cache dir in case you want to save it in the cache. Also, you have specific directors in your external app directory. So you called for get external files dir. You specify which type of directory you want, like for example, a picture, and then you can write into it. And then the most interesting thing that you don't need permission for that at all. And there is all kind of dirs, like for audiobooks, for photos, download, movies, music. Basically, you can manage the same as you're managing today in the general storage. You can manage inside your external app storage. So before you're actually running to save everything in external app storage, there's one important thing, that actually you can run out of space on the device. So it's important to check the space before that. Otherwise, you will get exception, and your user will not understand what's happening, and you will not understand what's happening. So there's a couple ways to query for the storage, so how many space you have to save your data. So there is like all the way. So basically, you get the path. You call something called statfs, that actually you give the path, and then you get the stat. So then you can query through the block size, and then you query for the available block size, and then you can divide one by each other. And then you can get actually amount of available size that you have to store your file. And then if you don't have enough storage, then you can call for something called storage manager. So it's basically the intent that you create with action manage storage. You put extra the amount of bytes that you need to be freed, and then user will see the dialog that, hey, move some storage out of your device. But actually, there is more. In API 26/27, depends what you're using in the storage manager. There is a different additional things that you can use. And these additional things is actually to allocate bytes from the cache storage when you ask. So how do you can use? So you grab the system service storage manager. You get your UID for the files dir, the one that you're going to use. You ask storage manager for allocate the bytes, the amount of bytes that you can allocate. You check that this is the amount of bytes that you need for your action, and actually you call for method allocate bytes with the UID of your app, of your folder, and the amount of bytes that you need. And basically, the system will allocate for you storage out of other cache directories on the device. And if you don't have a storage, so you basically call for action manage storage, as we saw before, and ask the user to free storage by himself. So actually, what I suggest to use, because it's actually allocating storage for you, it's worth to implement both ways, like the one that allocating from the storage manager bytes that you need, and the other one is the old. In some research that I did, I saw people are using like try catch, like trying to create file and write something in it, and then like catching IO exception, and not really understanding that the problem is not that they can't save the files, that there is actually the problem with the amount of storage, and also it's shaving the old problems that related to other problems, like it might be a problem with the read-only storage, right? So the SD card can be locked to the read-only, and you will never know about it. So its best way is not to wrap everything in try-catch, but to use the granularity for each and one of the cases, like hold the available storage by itself, the read-only mode by itself, etc. Cool. So we halfway there. So we learned about the internal storage. We learned about the external app storage that we can access without any permissions. And now there's actually the cherry of our session today is the shared storage. So the special thing about the shared storage is actually it's the main goal of it is that actually this storage that accessible by other apps. So if you want in your app, or you plan that user will be able to access the same files from the other apps, and you want also those files to survive that user uninstalled app, like photos or documents that user downloaded, you have to use this API. You have to use this shared storage, and you have two types of actually shared storage. One of them is Media API, Media Store API, called Media Content, and second one is a storage access framework. The one is using as a sound for media, like audio, photos, and videos, and the second one for the documents, like PDF, Word docs, etc. So let's start with the Media Store API, and bits and bytes of that is actually you don't need any permission to write and read your files from this Media Store from the Media Store. Why? Because every time when you create a file, is actually it's write down who is the owner of this file inside the field called owner package name. So once you download that file from the internet via your app, or you created the file via your app, you actually get persistent access to your file up till you actually deleted the app, or not you, the user deleted the app. So in this case, you actually need to check the access for the media storage for this file. So kind of it's very good practice not to rely that you will always have access to this to your apps in the media store, to your files in the Media Store API, but always to check the permission if you have this access. And to get this access, you actually will need the read external storage. So because once your app is deleted, you no longer the owner of this file, and this file is treated as all other files of other apps. So in this case, you will need to ask for the read external storage permission. So there's in Media Store API, there is 4 types of, it's called collections. Basically, it's divided in 4 different ways of working with the files. There's one for the image, it's actually querying all folders that contains files like DCM or pictures, and you can access from via mediastore.images. Same for the video, so it scan all the folders like DCM, movies, and pictures for the video files, audio files, and also there is download files that are the download files are stored in the download directory. There is a special thing about the downloads collection that you will never get access to the downloads to the files in the download folders that not belong to you. Even if you have external read external storage, if you will even have write external storage, nothing is going to help you. You will just don't get the access for that. For that, you need to use SAF API, and we'll talk about that a little bit later. So basically, how to create the files via Media Store API. The recipe is actually pretty simple. So first, you create content values that describe the content with something called pending flag. What does it mean, pending flag? Is actually think about that you're going to write very large file, and if there is other apps that get notified about the new files appearing in the directories, you don't want to be notified till we'll finish to write the content of the file. So this pending flag is actually marking to the system not to notify other observers of this API about the changes in the directory. So after you create these content values, you actually need to call via content resolver insert. And then you get back the URI that you can use this URI to write output stream, actually to write the content itself. And then once you're finished to write the content to the via the content resolver, you're actually disabling the pending flag to notify that you finish work and it's good to go. So how it looks in the code, we grab the content resolver from the context. Then we actually get the query to our media store audio API. So remember I said that there are different collections. So for every different collection, we have separate URI to store the files. So here we are actually going to store like song, MP3 file. So we are grabbing, we're going to the media store.audio.media again content URI, and we specify the external volume that are currently a primary to store our audio collection, like audio file. And then actually we create the content values where we put the display name and also our pending flag to mark that work in progress. So we take this song details, we take the collection, URI collection, audio collection, and we call to resolver with the insert with both of them, and we get back the URI of our song itself. So actually, this is the URI. URI is very similar to URL, just as a unified resource identifier. That actually this is the path to your file on the device itself. So what's left to do is to write our content into our URI. So there's a couple of ways to do that. Here I will show the example of file descriptor. It's something that comes from the Linux world. So basically, you can you call open file descriptor. You get the song, you put the URI, and you put permission W, mean write. So if you have access, and you have because you created this file, you can freely write via file descriptor to your file the content. Once you finish to write your content, then we need to disable the flag, right? Disable pending flag because we finished. So we'll take our details, we clear all our stuff, and then we put a new flag. We put is pending 0, and we will call on a resolver with the same content URI. We'll call update with the new song details, and this actually will update the pending flag to 0, meaning we finished the work. Cool. So we know how to create file, but now we want to get all the files out of the system. So how we can do it, and actually we can use something called query. So we take the content resolver, we call query on it, and we need to provide. So it's very similar if some of you work with content provider. So basically, it's the same concept. Media Store API is actually using the content provider under the hood. So we need to provide something, actually the URI, the one that URI to the, for here example, we're using URI of video. And then we need to do something called projection, selection arg, and so order. So what does mean projection? Projection is actually what fields from the data we are interested to get. Meaning like it's very similar in SQL is like select which columns from table you want to use. So here we're like taking ID, display name, duration, and size. And then a selection is basically very similar to SQL. SQL is to SQL is like where close, right? So what we want to filter, like for example here we want to filter all videos that are length, their duration more than 5 minutes. And in selection args, we are like supply the value itself. Like here is 5 minutes. And sort order is basically how we want our data to be sorted. So here, for example, we're sorting by display name in ascending order. When we querying the single file, so we don't need to provide any selection because it's only a single file. So our URI already pointing to the file and not to the directory. So we just apply projection, like which fields we're interesting, and the rest we can do the null. We get a query. So what to use? We get the query that holding the data, but actually it's not holding the data itself, but it's holding the pointer to the data. And now we need to go over this pointer and actually to query the data. So the way to use it is actually to, when you call the use, you get the cursor, and you actually moving the cursor every time to the next data. So we start to move to next, and then it's pointing to the first data that we received, and you can iterate over the data. So what's data we received? We received something called metadata. So actually, it's basically all the data about the file that we are querying for. And there is a lot of fields. I try to highlight the most important ones. So there's the owner package name. So basically, what's the package that owning file? So this is how it's verified that you can access this file without permission from the user. There's like display name that you can show to the user. There's meme type. There's ID that's very important for further usage, like you want to get direct URI to this file. Also, there's two fields that people are used to confuse between them. It's like underscore data and relative path. So underscore data is actually the path to the exact path to your file. But actually, it's not very recommended to use it because the volumes, the path could be changed. So it's very useful to use the relative path. So like to concatenate between, as I showed before, like get external storage method plus the relative path itself. And then you can actually access it. There's a lot of columns that are available in the query. So for each collection, you have separate columns. So like for video columns, for photo columns, for audio columns, all of them you just can see in the source code. Just go to video columns, and you will see all the columns that are available for you, or basically all the data that you can check about the file that you get. As I mentioned before, the best way to access files is via URI. And not via relative path, because it might change. It might change between external and primary storage, especially when you have to deal with the SD cards, extension cards. So the way to create this URI is very simple. Once you get the file, the data, you can get the column called the media._ID, and basically this is a unique ID over the system of the file. And then you actually can concatenate between external content URI and the ID of this concrete file. And then basically you will get the URI that's unique across the system. So you can use it to access this content anytime when you want. And to access the content, so basically here is an example again of file description. So you take the resolver, you call open file description. You put the URI. Basically here you're using video.uri with a read permission, right? Because we're reading. And then we get a file descriptor, actually parcel file descriptor that we need to take file descriptor out of it. And we create a new file input stream, and then we can read, like for example, here I'm using buffer to read the chunks of byte arrays inside something. Also, you can use like input stream. It's same way to do. It's two different ways to do the same. It's just a matter of what you prefer. To overwrite the content, so basically we want to we get URI. Now we want to overwrite, or actually to write inside the content. So with the open file descriptor, we can call the same thing with the write permission, right? To open the stream and start to write into it. If we don't have a permission, to write in the file. Like, let's say we don't, like when we don't have a permission, when this file is not belong to our package, right? That we didn't create it. So in this way, we will get something that called a recoverable security exception. And we say that this package don't have access to our URI. So if you want to learn more about the recoverable security exception, there is a lot of documentation. But the truth is actually this is a kind of security exception. It's called recoverable for a reason, because we can recover from it. We actually can ask user to give us permission to edit this file. So how we do that? So you wrap it with a try and catch, right? The access to the file. Once you get this recoverable exception, we call for intent. We actually create new intent for the sender. So there's a specific user action intent sender. So basically, it's kind of wrapper of pending intent, if you're familiar. So basically, what we want to do, we want to send the intent to the system that we want to recover the permission for the system. We send it. It's working the similar way as work start activity for result. So we actually call the start intent sender for result. We pass the activity, the one or that will hold the on request on activity result with specific request code, and user will receive this pop-up with ask to grant our app the permission to modify this video. Cool. So we know how to read, we know how to write into file, how we delete. So delete is pretty simple. It's kind of to record to, it's called to resolver.delete with a content URI and to specify the ID of the media that we want to delete, for example, if it's folder. But there are some problems with the delete. I found that a lot of there's inconsistency between the devices. I will send my presentation later that you can access and read more. But bottom line of that said, that sometimes it just doesn't work. Like I'm trying to delete the file, it's not deleted. And the way to solve it today is to use storage access framework, and we'll talk about a little bit later. Also, there is a new update in Android 11 about how to make batch updates. So we want to write in the multiple files, or we want to delete multiple files, and instead of user to allowing it each one by one, we can do it in the batch. So we basically create a new delete request. We pass the URIs of the files. So here, example, we want to delete all the files that we have permission to them. Just for curiosity, we can do that. So basically here I created take all URIs, filter the ones that they have a permission with the check permission, with a grant write URI permission, and then actually we call start intent sender for result to delete those files. And then if user approves, all these files are deleted. So basically what you should do, Media Store API, some of them available 10, some of them available 11. I suggest you to start to work with the Media Store API from Q, and then if no, to hold it in the old way, using it regular files, it's going to work. And also don't forget about in the old way, you will need write external permission. Cool. But it's not over till it's over. There is a SAF to cover, the last thing. So what does it mean, SAF? When I Google it says Singapore Armed Forces, but actually it's not. It stays for the Storage Access Framework. And actually it's the thing that exists a long time ago. Just nobody really don't like to use it because the API is not really so friendly, kind of. But we should and look in the Jan face, how is he happy about storage access framework. Because the most cool thing about that you actually don't need permission to access your files, or actually to use read or write external permission. The recipe to work with mostly with all things in the API is pretty simple, kind of. So you create the intent with action that you want to do. Users see the system picker and choose what you want to do with it, like granting you access to document or to the folder, or actually not. Then if he decide to grant you access, so you will get it, you get the access, your app package is write it down as the one that have access to the to this document or to the folder, and you get the results in on activity result via intent with a URI. So how it looks in the code. So for example, we want to create the doc. So we create intent with action create document. Then we add some extras, like for example, that category is openable, the type is a PDF, then actually also the name, like Marvel Universe PDF, just because I really like Marvel. Also, we can specify like where we want user to create a doc. It can be default if we not specify system default, or we can say that we want to save it in specific folder, like our folder. And then we call for the start activity for result with this intent and some request code. Once the user approve it, we get it in on activity result. If it's our request code, like a PDF file, should be here, create PDF file. Then we can get the intent itself, the data, ask for the data that they basically URI, and we can open output stream on this URI and write our content into this file. Same goes for the open, like just the different action. You like action open document. You can specify which type you're interested in, and then actually user will see only files of the type that you specified. Also, you can specify initial folder, and you call for start activity for result. Another thing is actually to accessing the directory. So in some cases, you want to access the whole directory. So you call for action open document tree, and you specify flags like grant read URI permission. And also I here specified persistent URI permission that we'll touch on a little bit later. And you call for start activity for result. And the user will see the dialog. You see the storage, and we'll see the specific folder that you want to access. And he will need to approve it. Worth to note that starting from Android 11, you can't give actually user or you can't ask permission to access root folder. Any root folder, doesn't matter on which storage it is. It can be an external on, I mean, like in SD card on your primary storage, and also you can't access to the download folder. So it's protected, and actually it's not belong to you. And so I mentioned that there is the grant persistable URI permission. Why I mentioned it? So basically, if you're not asking, when user give you the permission, is actually it's bounded to the life cycle of the process. So once the process is dead, your permission is over as well. So you will need to ask it again. So the right way to do that is to persist permission. So you can write yourself your application, your package to get the persistent access for this URI. And the way to do that is to call for take the content resolver, create flags with mask. So basically you take grant read URI permission and write URI permission, depends on what you want. And you call for the method take persistable URI permission with the URI that you want. And you will save this access for your application till it uninstalled, which is good. However, there are some certain drawbacks of this. So first of all, the amount of URIs that you want to that you can save the persistence, the permission, is capped to 128 URIs. And basically, when you will ask for 129 permission, it will go and revoke permission from the first one that you're asked. So basically, you can't really hold permission for more than 128 URIs. Maybe it's going to be to change in Android 11, but as today, it works in the same way as it works in Android 10. And you can actually check how many URIs you have permission, you have persistent permission, by just calling on the content resolver, persistent URI permission, and you will get the full list of URIs that you're holding the permission to read and write access, or read and write access. But number two is actually that the file itself, right? So you have a URI, but file itself can be deleted or moved anytime. So to holding this persistence is not really always helpful. So you need to try to wrap it in try catch every time you're accessing the URI and address the file not filed exception and the security exception. Another suggestion that I found very useful is actually to work with with documents inside your own folder. So instead of holding permission for each and one of the documents, you can hold the permission for the whole directory, and then in this way to work with the files. So basically, you can ask the permission to specific directory inside of your inside of the device, and then once the permission is granted, we can grab the URI of granted permission of a folder, and then we can create our new folder. Like here, I'm using document library, document file library is a part of Android X, and this is actually I can take the directory, the one that we have granted access. I can create my own directory inside of that. So I will hold the permission for it for itself, and then I can easily create new files inside this new directory and write into it. And I will always have this access to the file because I have read and write permission for the directory that I created inside the granted directory. And this way, actually, it's make the life of persistent URIs much easier. Of course, we can delete files. So basically, we can call the documents contract delete document to pass the resolver and URI, or we can just call the content resolver.delete with URI, but it's only supported in Android 11 in API 13. There's also kind of, I called it a nuclear bomb, storage permission. So for the apps that really need to access to whole storage. So basically, we have new user permission called manage external storage. Is actually is same as once was write to external storage. So we have manage external storage permission that we can ask. And once we ask, user will see this the screen that actually we need explicitly user to go choose which storage he want to allow us to manage. Like let's say we choose the we choose the scope storage, and then our app scope storage, and we actually can allow access to manage all files or not. So it's not very user friendly. So basically, and the main drawback about that Google says they are going to monitor every single app that asking for this permission, and it will require explicit approval from the Google Play team, which takes time a lot. Cool. So what to do on the rest of the devices is to ask write external storage. We have special flag in user permission. User's permission is Max SDK version. So we can specify it like we want to start from Android Q, from one that Android Q, from Android 10 to work with the new storage, right? So we can specify Max SDK version for user's permission and to ask this permission only up to this version and not after that. So for the backward compatibility, we can ask for external storage and use Max SDK version. Oh, so we're almost finished. Only a couple of things left. So about the migration. The thing is that actually, so you decide that you're the brave one. You're going to target Android 11. You're going to migrate to the media store API or to the SAF storage. And then actually your user upgrade your app, your target to Android 11. And then poof, you don't have any access to the previous storage file because they're stored in the old way. And you don't have any longer access to that. User is frustrated. You are going mad. Everyone is in a bad shape. So the strategy to work with that is actually is very similar to how we work with a database, right? So we can't really, when we upgrade the database, we can't assume any state of specific version of the user. So we need to handle all cases where user upgrade from the old version to the new one. And there is dozens of the old versions, right? So and so every time we need to hold the case that user actually update our app from very, very, very old version, whereas he stored his files in the old way. And now we need to migrate them into the new storage, if it's a SAF or it's a media store API. And to help us to do that, we have special flag in our manifest called preserved legacy external storage. So basically, it's give us a option to work with a old file access storage API, even if we're targeting Android 11, up till user actually uninstall our app. So basically, we can really safely migrate our files from the old storage, like different folders that not in our internal, to the via media store API to grant the access and to continue to work with the files. So the last we're almost done. So the next question is actually when to migrate to the new storage, and say so you need to plan, you need to think, but actually it's going to happen very soon. For some apps, it requires a lot of work. It's kind of to wrap API between the old way, the new way, different SDK versions, and it's require a lot of planning how you migrate the data, how you work together with that. So I suggest to start to plan it today, to think about that. Now you have a lot of meat of knowledge, and you have all the tools to do that. So we're finished. I hope you enjoyed and not really suffered from all this. There are still a couple things that we didn't cover, and it's like you need to explore by itself. There's a major problem with this SAF, and it's actually when the user opened the system picker. The system picker is something that provided by device manufacturers. And it's actually not always works good with the SAF. I hope it's going to be fixed soon. Google working hard to introduce more tests to verify that the device manufacturer actually compatible with all SAF APIs. But it's something that you take in account. Also, there is some problems with the cloud-based providers like Drive that they treat the files in different way, but our users still see them and they're queried as a data. So also Samsung have all their own file cloud-based providers, and their also API is not aligned. And also there's a huge world of sharing your files via file provider. Just we have already, it's not in scope of our lecture, but it's worth to mention, worth to explore it's part of the changes as well. That's it. That's it for today.
Phew, now we can exile. I saw that when you showed this person who was waiting, I saw that it was an end. No, it's not an end. I still have some insights, some summary. Yeah, now you can relax. Everything was fine, but it's mind-blowing. So many information, file API, media store, save. It's like really, it's too much work and too much where you have to think. You have to think about the future, about the current situation, about the current code base and everything. So you have to synchronize everything. So it's, yeah. I know that you suffered a lot in your application when you was migrating from one version to another, right? So you made lots of insights out of there. So okay, yeah. Okay. Basically, what I saw so far, we did not have much questions, but I prepared mine, so I can ask you my question while our audience will write or type any of the questions. I think that everybody went to think about this, to try to
process it.
Yeah, to process it, right? To understand everything that you said. Okay, one question. For example, we want to find all the files of the particular type. For example, PDF files. We want to find all the PDF files on the device. Do we have any possibility? How can we do this?
So basically, there is a couple ways of achieving them. The simplest one will to ask this nuclear bomb permission manage external storage, but it actually will you will have hard times to explain Google why you need to scan for all PDF files in all storage. Also for once you will get this manage external permission, actually you get access for all other apps folders. So intentionally or not intentionally, you actually breach of the security. So this is the one way to achieve that. Another way is to ask user to grant it permission for some folder, like to think about the folders that can hold these PDF documents, like download folder could be the good folder, the document could be folder. So basically, it's actually asking the user, hey, you want me to be very proactive and explain why you need this permission, and then actually to ask the user in 2 steps. The first step is actually, hey, give me the permission to the folder that have all your PDF files and the one that you want me to scan. And then once he give you access actually to query and give the insight from that. Basically, this is it.
Okay. By the way, what do you think about this nuclear bomb permission? What kind of apps can request such permissions? What do you think?
So obviously, all the file managers will request the permissions. I think all apps like virus scan will ask them as well, to find the malware. So I think basically only them.
Yeah. Okay. Okay. Good.
No Flash apps that asking to manage external permission.
I see. Okay. We still don't have lots of questions in our chat. I think but we're still waiting for you for your questions, for where we can help you. Okay, here's Vladislav said, does Monday app ready for November Google Play restrictions related to scope storage, or you're just using request legacy external storage in manifest file?
So it's basically, I will tell you it's both. So it's funny story that we had a lot of problem with the files. We work in the old way. And like a couple months ago, we decided we want to rework the way we work with files, and we went to the Media Store API. So we migrate to Media Store API, but because of the different ways how it's handled, we're still requesting for legacy store external storage. But yeah, the barrier of migrating to the new way is much lower now. So we're using both like Media Store API and also SAF for accessing the documents. And we still also accessing legacy external storage sometimes, like, so, but we like almost there.
Almost there. Okay. Yeah, I see. Okay. So, and the next question from my, what about if, for example, users start downloading several files, and how he can create, like, how he can implement this mechanic to access several files at the moment?
So there are a couple things you need to remember. That all access to all writing file is actually IO access. So basically, it should happen on separate thread, not blocking UI thread. The best way to do that in the background, like, so the app can be closed anytime, right? You can get a call and your app can be went to the background. So the best way to do that is actually to think about foreground service, right? So like, can you postpone it or you can postpone it? If you can postpone it, then you can like write it via the thread. All is good if in the background work will succeed. If not, not to forget that after 1 minute, the app is closed. It actually can be killed, and you can't really run. And then all wake logs will be released, right? So this is actually what happened in the background. In some devices, it's even happened even earlier. Like, I know that OnePlus very aggressively cutting the application doing the massive work in the background. So the way to do that is actually to using the Foreground service. A Foreground service with separate threads or coroutines that process that and writing into the files one by one, and also letting the users. This is the process that's happening right now.
Okay. Yeah. That's good. That's good. Okay. So the next question: why doesn't WhatsApp save media to external storage?
I think it's a couple of reasons. They try to be very security oriented. So there is like two options in WhatsApp, as far as I know. You can save it in the external storage, like external, I mean, like in the SD card, and you can store it in internal storage. WhatsApp tried to be perceived as very privacy-oriented app with end-to-end encryption and other stuff. So I think it's more that by definition, we will store all the files in internal storage. And if they use, because it's more secure way, because no one really can access the internal storage on Android 10 and etc. And then if the user really wants to share it with the rest of the world, then he need to explicitly go and share it from them via the file provider API.
Yeah, I think the same. Okay. I see Dmitry asks this probably similar question. The last, like the same question that I have, similar question about the Android Academy. What the next for Android Academy?
What about it?
Yeah, what about it? What about the next? What about the future? And Dmitry asked about the courses. When the new courses.
Yeah. So the future is bright as always. We going. First of all, we have new T-shirt of Android Academy.
Yeah.
Android's in black.
It looks great. Yeah, it looks great.
The second one, there is. So we're doing a lot of improvements of the way how we work, and we try to like. Corona times brings us a lot of opportunities that we can utilize, and one of them is actually that we can doing events together with different locations. So we thought that it could be really good to have a unified course that will bring together folks from St. Petersburg, Moscow, and Belarus, because everyone's speaking the same language. We can join forces and produce together something very, very cool, and also to renew the syllabus, also to talk not about only fundamentals and advanced course, also to talk about other like soft skills, like interview process. Also we really want to improve our mentorship program, the way how we work with the mentors, the way how mentors work with the students and folks that attend under the academy different courses. The opportunities are endless, and we are going to attack one by one to find the best way possible to give as much as we can to our students, to our folks that participate in the academy, and also for us to learn more.
Yeah, I can't add anything, because you just mentioned everything that is important for us, and that is what we look for. Yeah, sharing experience, making, helping others, and yeah, it's one part of our future, our Android Academy future. So yeah, 2 hours, almost 3 hours. I didn't even notice how that 3 hours already met. Yeah, it was crazy. It's so many information, so many insights, so many things. I hope that everyone found something interesting, something that really helped them to understand all the new features that are coming, that are really very close to us, and we should know how to support them well and how to deal with them. So yeah, it was it's really crazy. It was amazing. I really like this session. I hope that the next session will be the same, or at least will be better, or at least the same. The next session is very close. So next
next one will be on the 21th of and we have special guests, right?
Yeah, that's true. Special guest, yeah.
So his name doesn't start with B. He's not living in he's not living in Israel, or he's not living in Russia, and he's not living in Belarus.
Yeah, that's true. So please be ready, prepare yourself, and stay tuned. You can stay tuned. We will announce it very, very soon. Okay, so I think that we can finish our session, right? I think we can leave you and for relax and to have some I don't know.
Thank you, Pavel, for moderating that.
Yeah, thank you. It was a pleasure for me to be here and to listen to so many smart people. And
next time we're going to listen to you.
Yeah, that's true. And thank you, all of you who answered the questions. Everything, we are very. All the questions were very interesting, and I think that we try to answer all of them. If something was not answered, please write to us or in the chat in everywhere, so we can connect and answer you. So thank you very much, and we are going to finish this stream. So see you in 2 weeks. Bye bye.